So hello again, Year 10, and today we're going to do an experiment where we're going to calculate the change in mass during a chemical reaction, and we're going to see whether that agrees with our calculations using our relative formula masses and our conservation of mass ideas. So the experiment we're going to do involves the oxidation of magnesium, very similar to the experiment you saw last time, burning the iron wool. And the first thing we need to know is what mass of magnesium we are starting off with. So on the balance here, 0.12 grams of magnesium. Now, just to make sure that this heats efficiently and effectively, the first thing Miss Richardson is going to do is she's going to coil it into a little spring shape. What would you call it? A spiral? Yeah, spiral rather than the helix. And then she's going to put that spiral onto the bottom of what's called a crucible. Now, it's quite likely you guys haven't used a crucible before. These are designed to be heated very, very strongly. Now, before we start heating, we need to know the mass of the crucible as well, with the lid. So let us weigh the crucible plus lid, 31.52 grams, and this will let us know easily any changes in mass. So 31.52, note that down now. Right, now Miss Richardson is going to turn this up to a roaring blue flame and start heating the crucible. And we do need this to get extremely hot. So we're using the crucible supported within a clay pipe triangle there. So that you can see there it's a clay pipe triangle. And also notice the way that it has been positioned on the tripod. That is the Star of David formation, as it's called, with the metal prongs from the clay pipe triangle sticking over the middle of the tripod. Don't be tempted to balance this the other way round with those metal prongs. Could you just point to a metal prong? Yes, with those pointing to the corners of the triangle, or you will end up with everything falling through. Now, the idea here is that we are actually going to heat this crucible until the bottom of it is glowing red hot. So just going to heat it a bit more just to ensure that that really is glowing beautifully cherry red. Now, occasionally Miss Richardson is going to use tongs to lift the lid off. So let's have a quick look inside. It's not glowing red yet, nowhere near hot enough. Now, one of the big sources of error in this experiment is the fact that we can lose product if we are over eager in lifting off the lid of the crucible, and we don't want to lose any product, or we won't be able to accurately weigh the crucible and the lid and the contents at the end of the experiment. So what we need to ensure is that we only lift the lid occasionally, and we don't lift it off so fast or with such force that we actually cause any of the product inside to go flying out of the crucible.
It's just starting to glow on the bottom.
Just starting to glow on the bottom now? Oh yeah, we can see a lovely cherry red colour, and I'm going to look in from the top now. There we go. Oh, right now. There, did you see the magnesium glowing beautifully yellow there? Beautifully white hot. And so we're going to put the lid on, we're going to let it heat a bit longer, and Miss Richardson is going to sporadically, maybe once every 30 seconds or so, lift off the lid and see whether the magnesium reignites.
That's a yes?
Yep, if it keeps igniting, then we know that the reaction hasn't finished. Now, she's not leaving the lid off, because as I said before, we don't want to lose any of that product. There you go.
Yeah.
It's still reigniting every time that lid is taken off, so the reaction has not yet gone to completion.
Yep. Really
Now
good.
there you saw, as that lid was lifted off there definitely was some smoke came out of that. And just bear that in mind as a source of error in this experiment. We are going to lose some product as the hot fumes cause some of the product to drift up out of the crucible.
That's almost done, I'd say.
Oh, I don't
It's
know.
just starting to
Oh, look at
reignite.
that.
There we go.
That's still glowing beautifully. And yeah, look at the cherry red colour at the bottom of the crucible. So that must be about 600, 700 degrees, that pot. So obviously one of the things to be aware of is just how hot the materials in this experiment are getting. And there are all those safety implications, hence the lab specs worn by Miss Richardson.
Yep,
Okay,
still glowing.
still glowing, still igniting there. This is showing beautiful patience from Miss Richardson, because often students at year 10, bored with the experiment, will just take the lid off, let the reaction go in one blinding flash, and then weigh, obviously losing quite a lot of their product in the process.
It's what 8-hour university practicals do to
Oh, there you go, still glowing
you.
beautifully.
Almost there though.
Almost there. And again, this can be beautifully cut down.
Yeah, do speed up. Speed up animation. I would go as far as saying that's almost
Yeah.
done. There's no
Okay. So we're going to turn that to a safety flame and remove the heat.
I'm just going to turn the Bunsen off.
And now we're going to let it cool down. Okay, so we've let the crucible cool down, and Mr. Reeves would really like to highlight to you Year 10 students that Miss Richardson has put it sensibly on the heat-proof mat to cool down. She hasn't stuck it on the desk, as this one here, because, as I said, it was 600 or 700 degrees. Now we're going to weigh it. A reminder, before the practical, the contents, including the lid, were 31.52 grams. So let's see whether it has gained or lost mass. So 31.52 initially. 31.56 grams, okay? So that has gained mass. Now what Miss Richardson is going to do is she is going to stick it back on the Bunsen burner, and she's going to heat it again to see if a bit of further heating to cherry red will cause any increase in mass. Okay, so after heating it back up to cherry red again, opening the lid a couple more times, we're now, and letting it cool down of course, we're now ready to see whether it has gained mass in this second weighing. Well, should we use these scales? Because these were the ones we used before. 31.60 grams. So the contents have gained in mass by 0.08 grams. Now, obviously, if we had the time, Miss Richardson would heat it up again and then try this again. That is what's called heating to constant mass, but that gives you an idea of the practical. Once again, thank you, Miss Richardson, and thank you, Mr. Reeves.
It's my pleasure.